Beneath the stunning blue waters of the Aegean, something ominous is stirring. Scientists have detected alarming ground deformation on Santorini, one of the world's most notorious volcanic hotspots. Satellite images reveal the island is rising, a potential signal that magma is moving beneath the surface. This is the same warning sign that preceded past eruptions, including the cataclysmic Minoan eruption that changed history. Could Santorini be waking up once again? What does this mean for the thousands living in its shadow? And just how much time do we have before the next big event? In this video, we break down the latest satellite data, analyze expert predictions, and explore the potential consequences for Greece and the entire Mediterranean. Stay with us, because what's happening beneath Santorini may be far more dangerous than we ever imagined. The rising ground. What the data reveals. Santorini, a breathtaking Greek island in the Aegean Sea, is more than just a tourist paradise. It sits atop a highly active volcanic system. The island's iconic crescent shape is the result of a massive eruption that occurred over 3,600 years ago, famously known as the Minoan eruption. This catastrophic event led to the collapse of the central part of the island, forming the modern Santorini caldera. Today, scientists are closely monitoring alarming signs of renewed activity, indicating that the volcano may be waking up once again. The latest geophysical data, including high-resolution InSAR satellite imagery, GNSS, Global Navigation Satellite System, measurements, and seismic graphs, reveal significant ground swelling beneath the Santorini caldera. This deformation suggests that magma is accumulating underground, exerting pressure on the surrounding rock and causing the land to rise. Similar activity was recorded between 2011 and 2012, when an earthquake swarm, caused by magma intrusion rather than tectonic shifts, triggered widespread concern. Although the magma did not reach the surface at that time, its movement outside the main chamber resulted in intense tremors. However, the current situation appears even more worrisome. The recent earthquake swarm is more intense than its 2011 to 2012 predecessor and is concentrated northeast of Santorini, beyond the well-known central caldera. This shifting pattern raises new concerns, as historical records indicate that caldera-forming volcanic systems like Santorini often experience repeated episodes of unrest before a major eruption. Geologists have also noted a distinct change in the inflation pattern. While the land rise in 2011 was centered within the caldera, the most recent data from 2025 indicates a significant shift in the inflation center. This suggests that the magma chamber beneath Santorini is evolving, possibly expanding into new areas or creating new pathways for potential eruption. Beyond the seismic and geodetic measurements, there are additional worrying indicators. Thermal imaging has detected localized heat anomalies in certain parts of the caldera, suggesting increased geothermal activity. Gas emissions, including sulfur dioxide, SO2, have shown an upward trend, hinting at rising magma levels. Together, these signs paint a picture of an increasingly unstable system. Scientists are now working around the clock to determine what these changes mean for the future. Could this be a precursor to a new eruption? If so, what scale of eruption should we be prepared for? And how much time do we really have before the situation escalates? With thousands of residents and tourists on the island, Authorities must decide whether to take precautionary measures before it's too late. Seismic activity. Echoes from the past. The Santorini volcanic complex has long been a site of geological intrigue, its seismic activity shaping both its landscape and history. Today, a new chapter is unfolding beneath its surface, as the latest seismic and geodetic data reveal concerning developments. The ongoing earthquake swarm, which began intensifying in late January 2025, suggests that the volcano is undergoing significant underground changes, possibly signaling a new phase of activity. As of February 8th, seismic activity has reached a critical level, with 3 magnitude 5.0 earthquakes occurring within just a few hours. These were followed by multiple aftershocks in the 4.8 to 4.9 range, further highlighting the system's growing instability. The current escalation comes after a previous spike in seismicity that seemingly quieted down on January 25th, only for a new, even stronger swarm to emerge the very next day. This pattern of short-lived quiescence, followed by rapid intensification, is characteristic of magma-driven activity, where underground pressure builds up before finding new pathways to release energy. Adding to these concerns is the detection of a deflationary trend that began around January 20th, coupled with a rapid north-northeastward movement, first identified on January 29th. This shift, still ongoing, suggests that magma is migrating beneath the surface, potentially seeking an outlet. Ground deformation data collected from January 24th through late 2024 has revealed a steady upward trend, accompanied by significant displacement in the northeast direction. The most recent measurements from early 2025 indicate that while vertical uplift has slowed, horizontal displacement continues at a notable rate. Long-term elevation data from 2022 to 2025 further support this trend, showing gradual but persistent changes in Santorini's landscape. The island's extensive GNSS monitoring network has played a crucial role in tracking these shifts. The SU station, the closest to the primary zone of deformation, recorded an elevation increase from 60 millimeters, 6 centimeters, in early 2024 to 100 millimeters, 10 centimeters, by early 2025, marking a total rise of 4 centimeters in just 1 year. This pattern of inflation is not limited to a single station. Additional GNSS stations, such as HOS, have also reported slight uplift, while others, located farther from the activity center, show little to no significant changes. This suggests that the primary deformation zone is concentrated in a specific region northeast of the caldera, aligning with the area where the strongest earthquakes have been recorded. Geophysicists are now closely analyzing these data to determine whether the magma chamber beneath Santorini is expanding, shifting, or potentially fracturing new pathways. If magma continues its movement toward the surface, the risk of an eruption, whether minor or major, will increase significantly. Authorities must remain vigilant, as the next few weeks could provide crucial insight into the volcano's future behavior. Could Santorini be on the brink of a new eruption? And if so, will it be a slow, effusive event or a sudden, explosive catastrophe? The clock is ticking, and every tremor brings us closer to an answer. What is causing the uplift? The recent ground deformation in the Santorini caldera has raised serious concerns among geophysicists, as the patterns of uplift suggest ongoing subsurface activity. This deformation is likely linked to either a magmatic source, similar to the activity observed during the 2011 to 2012 unrest period, or a deeper magma intrusion along a northeast-southwest axis. In either case, the data indicate that pressure is building beneath the island, potentially setting the stage for further seismic and volcanic events. Satellite imagery and geodetic measurements spanning from October 2023 to January 2025 reveal significant land uplift across key areas of Santorini. Certain zones have experienced an annual rise of approximately 40 millimeters, a rate that is consistent with magma accumulation in the upper crust. The most pronounced swelling is occurring in the center of the caldera, as well as along the western and northern inner edges, where surface expansion is at its highest. Interestingly, while much of the island is rising, some areas along the eastern caldera exhibit signs of subsidence, meaning they are sinking slightly. This suggests a complex interplay of underground forces, potentially driven by shifting magma reservoirs or localized fault movement. Such contrasting patterns of uplift and subsidence are often observed in large volcanic systems, where different sections of the magma chamber experience varying pressure dynamics. The latest set of satellite images, particularly those obtained from the Sentinel-1 satellite, provide crucial insights into these movements. The data, analyzed using interferometric synthetic aperture radar technology, reveal clear patterns of ground velocity changes. The red coloration on these maps signifies areas of upward motion, indicating that magma or hydrothermal fluids are likely accumulating beneath these regions. The most substantial uplift, around 4 centimeters per year, is being detected near the picturesque village of Oya and the northwestern edge of Nea Kameni, a volcanic island within the Santorini caldera. Nea Kameni, the youngest part of Santorini's volcanic complex, has long been a hotspot for geological activity. Past eruptions in the area have been largely effusive, consisting of slow-moving lava flows and steam explosions. However, the current rate of uplift in this region raises concerns that a more energetic event could be developing. If magma is actively moving toward the surface, the potential for new eruptions, whether minor lava emissions or more explosive activity, cannot be ruled out. Beyond the satellite imagery, additional signs point to increased volcanic pressure. Gas emissions, including sulfur dioxide, have shown a gradual rise, indicating deeper magmatic activity. At the same time, thermal anomalies detected near Nea Kameni and parts of the submerged caldera floor suggest heightened geothermal activity. These factors, combined with the persistent seismic swarms recorded in early 2025, paint a picture of a dynamic and evolving system beneath Santorini. Scientists are now working to determine whether this uplift trend will continue to accelerate or stabilize in the coming months. If inflation persists at the current rate or intensifies, authorities may need to prepare for possible volcanic activity. The biggest question remains: is this the early stage of a new eruption cycle, or just another period of unrest? While no definitive answers exist yet, ongoing monitoring efforts will be crucial in predicting Santorini's next move. Could Santorini erupt again? While there is no immediate evidence suggesting an imminent eruption, scientists caution that the increasing seismic activity and ground deformation could indicate the early stages of magma accumulation beneath Santorini. Similar patterns were observed in the lead-up to past eruptions, including the devastating Minoan eruption around 1600 BCE, which reshaped the island and wiped out the ancient civilization of Thera. Though modern monitoring tools allow for real-time tracking of volcanic changes, predicting exactly when and how an eruption will occur remains one of the greatest challenges in geoscience. Historically, Santorini has experienced multiple eruption cycles, with the last significant volcanic activity occurring in 1950 on Nea Kameni, the small island at the center of the caldera. That eruption was relatively minor, producing lava flows and steam explosions. However, the current signals, increased seismicity, ground uplift, and changes in gas emissions suggest a more substantial shift in the magmatic system, raising the possibility of a future eruption. The question is not just if Santorini will erupt again, but when and how powerful the event might be. If an eruption were to occur, the consequences could be catastrophic. Santorini is one of Greece's most popular tourist destinations, with over 2 million visitors annually and a permanent population of approximately 15,000 residents. The island's unique geography, steep cliffs and narrow roads, could make large-scale evacuations challenging. Authorities have emergency plans in place, but would they be sufficient if the volcano were to erupt with little warning? Experts suggest several potential eruption scenarios, each with different levels of risk. A small eruption, a localized event on Nea Kameni, similar to the 1950 eruption, could produce slow-moving lava flows and minor ashfall, causing disruptions but no widespread destruction. A moderate eruption. A larger event could involve phreatomagmatic explosions, where rising magma interacts with seawater, leading to violent steam-driven blasts. This could generate significant ash clouds, affecting air travel and daily life on the island. A major explosive eruption. If magma accumulates at shallow depths and pressure builds rapidly, a caldera-wide event could occur, producing large pyroclastic flows, tsunami waves, and widespread ash fallout across the Aegean region. This would have severe consequences for Greece and neighboring countries. To prepare for any scenario, Greek authorities and volcanologists are intensifying monitoring efforts, analyzing seismic activity, ground deformation, and gas emissions in real time. Contingency plans include early warning systems, evacuation drills, and public awareness campaigns to ensure residents and tourists understand the risks. The coming months will be crucial in determining whether the current unrest stabilizes or escalates. If uplift and seismic activity continue to intensify, Santorini may be entering a new phase of volcanic activity, one that could eventually lead to an eruption. The island's dramatic history serves as a reminder that volcanoes do not erupt without warning. But when they do, they can change landscapes and civilizations forever. The question remains, is history about to repeat itself? The future of Santorini. Expert opinions. As seismic activity and ground deformation beneath Santorini continue to increase, volcanologists around the world are closely monitoring the situation. While there is no definitive timeline for a potential eruption, experts stress the importance of constant vigilance, advanced monitoring techniques, and comprehensive risk assessments. Maria Papadopoulou, a geophysicist specializing in seismic activity in the Aegean region, warns that the current patterns closely resemble those observed before previous eruptions. The ongoing uplift, combined with increasing seismic activity, strongly indicates subsurface magma movement. While we cannot say for certain that an eruption is imminent, continuous monitoring is crucial. We must analyze whether this trend will stabilize or continue to escalate. Thomas Klein from the European Space Agency emphasizes the importance of satellite-based monitoring systems, particularly technology that allows scientists to track even the slightest ground deformations. With this technology, we can detect even the smallest changes in land movement. Data from satellites provide us with invaluable real-time insights into how Santorini's magmatic system is evolving. These measurements allow us to anticipate possible future changes and refine eruption forecasts. Elena Vasiliou, a volcanologist at the University of Athens, highlights the significance of gas emissions in eruption forecasting. Recent measurements indicate a gradual increase in sulfur dioxide and carbon dioxide emissions, which are often associated with rising magma. Gas emissions are a key indicator of volcanic activity. The increased sulfur dioxide output suggests magma is approaching the surface, though it remains uncertain whether it will erupt or continue accumulating underground. Experts from the Hellenic Institute of Geodynamics and an international volcanology research program have also shared their perspectives. They note that while Santorini has a history of unrest that does not always lead to an eruption, the current activity is among the most intense recorded in the past 50 years. In response to this heightened activity, Greek authorities and the Santorini Volcanic Monitoring Network have expanded surveillance. Additional measurement stations have been installed, and regular aerial surveys are being conducted to detect temperature changes in the ground. International collaboration is also increasing, with scientific organizations from various countries providing resources to study the Santorini caldera in real time. Despite the uncertainty, most experts agree on one point: Santorini's volcanic system is evolving, and its future remains unpredictable. Whether this leads to an eruption in the coming months or another prolonged period of unrest is still unknown. However, scientists emphasize that preparedness is key. Greek officials are improving evacuation plans, increasing public awareness, and testing emergency response strategies to ensure the safety of both residents and the millions of visitors who come to the island each year. The next few months will be crucial in determining whether Santorini is entering a new eruptive phase or simply experiencing temporary volcanic unrest. As researchers continue to monitor developments, the world watches closely. Will there be a new eruption, or will the activity subside? One thing is certain: the future of Santorini is still being written. Conclusion: what happens next? The situation beneath Santorini remains dynamic. And while there is no cause for immediate panic, the data is clear. Something is stirring beneath the surface. The question is not if Santorini will erupt again, but when. As scientists continue to monitor the island, new data will shed light on the evolving situation. Stay curious, and who knows what Santorini will reveal next. Leave a comment below and let us know which part of this discovery amazed you the most. Do you think Santorini could experience another massive eruption in our lifetime? We'd love to hear your thoughts and theories. Don't forget to like, share, and subscribe to stay updated on more amazing discoveries and hidden wonders from around the world. Hit the bell icon so you won't miss our next adventure.